Hello and welcome back to np.polyfit. I will be going over how to actually plot the graph and plot the line of best fit itself and how to create legends in this video. In the last video, I went over getting our x and y value terms for the line of best fit. So if you haven't watched that video, please go back and watch that and then come back to this one. Start, we'll be using the plot.plot function. Plot.plot and plot.scatter, which I'll use in a second, are covered in great detail in Python 4, so please watch that video on graphing and plotting before you come into this one. Plot.plot, we want to plot the x and y values for our line of best fit, which if you can remember from the last video, was line x and line y from up here. So line x, line y. These values, the line x values are here, and the y values are here. What this is going to do is it's going to plot each x value with its corresponding y value. So 1 here to 2.0357, whatever. And we also want to plot the individual points themselves, which allows us to see if there's any outliers. And that's just plot.scatter, which is covered in Python 4 as well. And we want to plot our original points, so this is just x and y. And then print that. You can ignore this line here. Now you have a nice quadratic curve, quadratic line of best fit with all the points plotted around it. Now we want to plot a legend. And a legend is like a block of text in the corner of the graph that acts as a kind of key to show the reader what each thing in the graph represents. And they're not very complicated. We're going to use this cell of code. So I'm just going to copy and paste it. I'm going to add a few things to it. So to create a legend, you add an extra parameter in plot.plot and plot.scatter. And what that extra parameter does is it gives the label in the key for what it's plotting. So plot.plot is plotting the line of best fit. So we want to make the label equal a string line of best fit. And that'll come up in the legend. And this plot.scatter is going to plot the individual points themselves. So we want the label in the legend to equal points. And then we just do plot.legend. Now yeah, that's our legend up here. As you can see, line of best fit is this unbroken quadratic curve here. Then the individual points themselves are represented by these dots. Now we want to print the equation of the line of best fit itself. So we want to use an f string for this. And I explained a bit about f strings in the last video, so please go back and watch that if you haven't. Start off by using the print function. Start an f string, just put an f at the beginning, and then start a string in the normal way using quotation marks. Like I said last time, f strings allow us to put variables and functions inside a string, which is very useful for what we're about to do now. So we start off in the normal way for equation of a line, y equals, and we want to put in our first variable, which is a, if you remember from the last video. A, b, and c represent the coefficients, which are the numbers at the beginning of each x term. So a goes before x squared, b before x, and c right at the end. So a colon dot 2f, which will round it to 2 decimal points, is multiplied by x squared plus b colon dot 2f multiplied by x plus c 2f. Make sure you finish off the string. And if I print that, there you are. Get our equation of our line of best fit. So you can see here it's not quite as clean as it could be. The coefficient to the x term is negative 6.63, which means in our equation we have plus minus 6.63. So to make that a bit cleaner, just go back into the string, remove the plus, print it again, and there you are. It's a lot cleaner. It's just minus 6.63x. Now we're going to add the equation of the line of best fit to the graph itself. So it'll be a bit like the legend, where it'll be a block of text inside the graph, but it'll just have the equation of the line of best fit in it. So to do that, we once again, use this code here. Just copy and paste that. Put it in here. And we want to use plot.annotate. And this has two parameters. The first parameter is just the text itself. So we'll just use this f string up here. Copy and paste that in. And the second parameter is where you want it to be in the graph. So it'll be a coordinate, an x and a y term. So the x term here is 2, y term here is 15. If I put in 215 into this parameter, then the line of best fit, the equation of the line of best fit will appear around here. If I do 110, it'll appear around here, starting at the value 110. Well, 215 looks like a good place. There's plenty of space there. So I will do 215. Close the brackets. And at the end, put plot.show. Print that. There you are. So you've got your equation of our line of best fit right here at 2. You see it starts at 215. If I was to change this to 110, you see it starts here instead now. There you are. Thank you for watching. We'll see you in the next video.